Thanks everybody for staying late. Like, I'm the last person. Like, it's a terrible place to be because I'm like, it's a beautiful day outside. I'm between everybody and beer, so that's not a good place to be. So thank you for staying. Also, one of the things I should say, I mean, those of you who go to lots of conferences will have seen this. You've had an amazing set of speakers here. It's been a really, really high quality set of talks, and I really hope I can finish up with something that that lives up to that particular level. So, you know, thanks to GOTO for organizing a great event. And I can sort of now say this, having tried to organize conferences myself. It's incredibly hard. It's really, there's so many emails you have to write. It's like you need your own mail server. It's really, really crazy. So I think there's something not quite, oh, I see stuff on that slide. There we go. I think we're all set. So, let me try not to speak too fast, because I have a lot of stuff, and we don't have all that much time. First things first, like, I'm not going to spend too much time talking about me, because you can read the me slide in extraordinate length from the site. Basically, I've done development work, I've done ops work, I've spoken to executives in a suit, and I'm now getting my hands really, really dirty with a fantastic big data AI platform running on Spark with a bunch of all kinds of other junk and Node applications, and it's really fun to get my hands dirty again. I've spoken at a bunch of conferences, and I do a bunch of other crazy stuff like that. That's me at the bottom there, so, you know. That was actually a fun jump. I'm actually not on that formation yet, but anyway. So, as I said, like, this is me as well, because that's you and there's beer, so I will really try to keep things short. I am well aware of my position in the order here. So what's the plan for this last talk of GOTO Stockholm 2016? I'm going to try and do something. We've had a lot of very interesting technical content, and there's no IP tables in my talk. I can show you lots of IP tables, but not now. I'm going to try and do two things. I'm going to try, on the one hand, to strike a balance between, you know, giving you some thought-provoking ideas around continuous delivery especially, and on the other hand, give you something where, you know, when you go back to work tomorrow and the real world implodes and your inbox is full, you actually feel like you have something you can take away and really do. Like, one of the challenges I always have as a conference attendee is incredibly motivating. You hear lots and lots of great stuff, and you go back on Monday and the web server's down and the inode table is full or whatever, and then, you know, the real world intrudes and all these lovely ideas just like, phew, back to writing shell scripts. So the plan really is to give a very brief intro to the extent that that's necessary of continuous delivery. I'm sure more likely than not you're all just entirely sick of the subject. I'm going to then do a little bit of that sort of thought-provoking stuff and try to reframe it along a couple of lines. And then we'll dive into, you know, what you read in the program notes, like metrics, and I'll talk a bit about microservices. And then we'll finish up by looking a little bit beyond, like, the go-live moment and to see, you know, what we can do with that. So there's a warning. People who've maybe been to my talks before know I'm a kind of, like, I like to engage the audience. If you have tired arms, bad luck. Like, I will ask a couple of questions, and just because I think it helps give a feel for where we are. So let me start with the first one. Who works in a company of, say, less than 100 people? Oh, there's a whole bunch, and maybe between 100 and 1,000? Like, large enterprise, like 5,000 plus. Ah, okay, so it's about a third. Interesting mix. So we'll have a very big spectrum of experiences. So maybe one other question, and I probably will see some correlation here. The time it takes on average in your apps, so of course if you're a large company you'll have thousands and thousands of services, it's very difficult to get an average, but something that wasn't written 50 years ago. How long it takes from the moment, like, a line of code goes into your repo to the moment it goes into production? Less than, say, a day. Okay, up to a week? Like 3 times a year, 4 times a year, that kind of stuff. Well, there's still a few. Don't be ashamed. All right. We know it's not your fault. Okay, so yeah, there is a mix, and I think this is part of the, you know, the challenge of the industry that we're in is that not every application written is brand new. Like, in fact, we all know the majority of the life of any line of code is in maintenance, 90% of it. So while there's lots of fantastic ideas, and, you know, sure, everybody would love to just migrate everything over to the next latest and greatest thing. We've been there before. It was, you know, web services and SOAP. Remember that? The similar kind of, everything must go to SOAP, and then we'll have a service-oriented architecture, and it'll be great. So the reality is stuff that we have stays around. So let me, just one quick question. I guess everybody's heard a whole bunch of CD. I'll phrase it the way I like to phrase it, and you'll see it sort of similar, but maybe also a little bit different. Basically, for me, it's about trying to figure out how to have a reasonably continuous, so an ongoing flow of ideas or features or whatever you like to call them to your users. It sounds very abstract and high level. What that sort of typically means, of course, in practice is that you have some way of going from stuff, code, to production systems on a reasonably regular basis. And that could be fully automated. Typically, if you want to go really fast, there's no really any other way to do it, but it could be semi-manual, that kind of stuff. The main characteristic, or one of the other main characteristics for me, is that it's moving away from this big bang release. Like, we all know what releases look like. They usually look a little like this, right? So you've been working for months and months and months, and there's an enormous list of features that you've implemented, and then you've had like 4 weeks of merge hell because, you know, everything is broken in the repository, and then you skip all the testing because you don't have any time. And then release day comes up, and then they open the floodgates, and then 10 million production issues come out. And it's really super painful. So we really don't want to do this anymore. So that's really, I think, to a large extent, what continuous delivery is about. Why? Well, I mean, there's a couple. The third reason, to some extent, is usually why the manager signs off on it. Because it actually reduces risk, which sounds very counterintuitive. You know, I don't know if I got a Swedish krona for every time I had the discussion, wait a minute, you're telling me to do stuff faster, but you're going to reduce risk at the same time? How is that possible? Well, we all know it's, you know, by doing making smaller changes, by not, you know, releasing the entire basin, but a little trickle of water into the production environment, then you reduce your risk. I think from a developer perspective, or even from a development manager perspective, what's maybe more interesting about continuous delivery is that fast feedback cycle. It's nice as a developer to get reasonably quick and efficient feedback. I mean, that's partially continuous integration, but the more we go to services that need to talk to lots of other services, the more you really need to test in a semi-connected environment to get realistic feedback. And then there's the sort of manager's version of that, which is, if we can get stuff into production more quickly, we can become a more responsive organization. That sounds very nice, of course. The challenge in selling this to your manager, it's very difficult to put like a dollar figure onto the idea of a more responsive organization. But we'll see this topic come back a few times as we go through this. So what are the motivating numbers? I mean, everybody's seen these. They're incredibly boring. You've seen them a million times. Like, there are some really cool companies out there that have some pretty staggering numbers. Like Amazon, something goes to production every 7 seconds or something like that. Of course, they have lots and lots of services, so that's not like every application it's 11 seconds. And I think one of the problems with this set of numbers originally was that people saw it and they're like, yeah, but I work in an organization for what, you know, doesn't have 10,000 IT people who are all the smartest graduates that we could find. We have other jobs as well, and IT is just a supporting function. And I think one of the big changes last year, and really the lesson of this slide is nothing more than, like, it doesn't really matter what organization you work in. Continuous delivery can be done in your type of organization as well. And I think that's a key lesson to take away, because it takes away some of this, yeah, but only the Amazons and the Etsy's of this world can do this. And admittedly, the kind of benefits that these companies get out of it aren't the same necessarily, but they're still incredibly significant. And the fact that, you know, the managers in these boring organizations, this is just big corp, big corp, big corp, if you're not familiar with them, they feel that this is worth doing and worth investing in. That sort of means that there are now more and more examples out there. If you want a much longer list, go to the DevOps Enterprise Summit. You'll find tons of examples of large corporations from pretty much every vertical: defense, aeronautics, pharmaceuticals. They're all doing something in this area. I think we did this already. Oh yeah, so I talked about these 3 benefits. I think there's 2 more that are kind of interesting, and I'd like to focus on these a little bit, because we'll come back to those, and they're kind of like version 2, if you like, or level 2. You know, if you've heard talk about moving to product teams, or the Spotify model, which I guess here people should be pretty familiar with, and this idea that we need to move towards more experimental organizations, these are other things that can come out of CD, or that CD is a kind of foundation for. And we'll revisit this topic a little bit later because it sounds a little bit more nebulous, but I'm mentioning them because I think in terms of when you come and think about what CD might mean for your company, having this in your context is very important. And so, with that, let's get to this discussion of what this kind of context might look like. So the typical kind of CD pipeline that you might have read about in the book, or that you might be thinking about when you think of your own installation, something like this. Like bang, source code commit, and then we do some build, and then we, the build passes, we do some functional testing, and then we do some deployment, and then yay, everybody's happy. That's great. And that's very useful and convenient. Or maybe your pipeline's a little bit more funky, like, it's not that trivial. You do some stuff in parallel, and you have some Docker thrown in there to spin up some more smarter. But however complicated that particular pipeline looks like, what I'm trying to get at here is that in a lot of cases, people think of a pipeline as a device of some technical nature to enable a commit to production flow. And that's okay. But think of the following way. So say you're an architect, you're building an enormous skyscraper. You're the chief architect, that's you there. And you're trying to think of this whole project, like there's a lot of stuff that needs to be done. And then somebody comes up to you, one of the workers, and he says, oh, look, we've just received consignment, blah, 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 some random identifier, which is like a git SHA. Then, to be honest, what you're going to do is like, huh? Because at the level of a large project, a commit means nothing. It's nothing. It has no relationship to the overall large thing. So to have a system that is great at moving commits into production, it doesn't help you understand anything in terms of the global context of how are we doing? How well are things going? And so I think one of the things we need to start to think about in terms of having the right context for continuous delivery is not to think about commit to production, but idea to user. It's about a flow of ideas or features or whatever you want to call them. And of course, ideas in organizations come in very different sizes. Like there are certain features that are really sort of commit sized, like we want to change the sort order of a list or something like that. And then it makes sense to have this pipeline because you have a nice commit message, it's a Jira issue, and then change sort order of list, and then you watch it go into production and you see, oh yeah, on this particular day we deployed that and that relates to this business feature, bingo, we're done. But there are many, many other ideas that your business cares about or your teams care about that are way bigger than a single commit. There are things like we need to support, Finnish or whatever, Japanese as a language. Like that is and especially as we start breaking down our applications into not monolithic things where you can do all the work in one enormous repository, but where you're basically trying to modify 10, 15, 20 different services. This work, it's not commit-sized. And so this sort of simple pipeline we have here that goes from commit to production really doesn't help you understand, certainly doesn't help that if you try to look at what we're delivering to our users, it doesn't really help you understand where you're going. And so you end up with a sort of pipeline structure that looks a little bit more like this. So it starts out with this, first of all, it brings in the notion of an idea or a feature, and this lives in wherever you keep it could be Trello, it could be Confluence, it could be a boring requirements management tool, it could be MS Project, whatever. But you need to have some kind of relationship between the idea and the stuff you're developing. And then, of course, that idea will be broken down into work that one or potentially multiple teams have to do, and that each one of those teams may be owning one or multiple services, and then each one of those services or repositories or mini applications or whatever, you'll be doing work in each of those, and then that work will be going through the pipeline. That's at least the traditional picture, and it'll be going to production. And once you can establish this link a little bit, then you can start to sort of understand, well, how are we doing with this big idea? How much of the big idea is done? But of course, this is kind of tricky because, in an ideal world, all these commits that the individual teams are making are sort of independent of each other, and it doesn't matter. You can just put them into production, and if the magic switch isn't enabled, then nothing happens. Who here knows the term dark launches? I'm doing your arm exercise. There's a few. Who feels that they have a production-ready capacity to actually do dark launches? So there's one. So that gentleman, go talk to him, because I think he knows something that's really, really interesting and important. Basically, this canonical model that you have all these independent teams, you have pipelines for the individual repos, they just run through to production, doesn't work if you have work that needs to be coordinated, unless you have some sophisticated ability to get the code into production, but somehow not activate it, so your users don't see it, so it doesn't break. basically we can't always just take the stuff and put it there. As an aside, by the way, I'm sure you've seen this kind of, we talk about microservices and containers, how they make everything flexible, and then people show this picture. To me, this is like the weirdest thing, because that is the biggest Big Bang picture that you've ever seen. It's like load everything onto an enormous boat and launch it in one go. That's ridiculous. Like, microservices look more like this. Individual things, like uncoordinated with each other. It's just a random thing at these events that always astounds me. Like, getting back to this, so what happens? Because it's actually not that easy to have these individual trains that sort of go to production independently of one another, is we end up seeing this kind of release train pattern. And if this is the pattern that you end up having, then you're in very good company. Facebook does this. Lots of very cool companies have not solved this problem, if you like. They solve it this way. So you have, you know, those individual teams, and they make their nice commits, and then each component gets tested to a certain level of, you know, reliability or a certain level of confidence, and then you push that into some artifact repository, you know, Artifactory, or Nexus, or S3, or your file system, wherever you want to put it, a thumb drive. And then once a day, or once a week, or once a month, or on demand, or whatever, you pull the latest and greatest release candidates, and then you do some kind of integrated testing, and then you go forward to deployment. And I think there's a very interesting question here, because it sounds fancy if you call it a release train, but this is a big bang. It's a smaller bang maybe than doing it once every 6 months, but this is still a reasonably sort of big-ish bang approach. We're moving lots of things into production at the same time. There's still more risk than if we can do them individually. Now, I wish I could come with some sort of standard answer to how to solve this problem. I think the real answer is that there are no easy answers. I mean, yes, dark launches are certainly the canonical way to address this and to look at it. There's a more radical approach you can take, which Dave Farley, who is the co-author of the Continuous Delivery book, somebody who's thought long and hard about this problem, says is that software projects are just wrong. Like, thinking of software as big batches of work that need to be done and coordinated and delivered, it's just bound to fail. It's just the wrong approach for developing software. So we should get rid of them. Well, if you work in a large enterprise, that's going to be an interesting discussion to have. We'll just scrap the idea of a software project. We'll move to ongoing product teams. I think Dave certainly has a point, and it's well worth reading his blog post, because I think he goes into some interesting detail to justify this assumption. But the idea that sort of software projects are a really bad idea, to me, only goes so far. Because if you think of the notion of sort of continuous delivery, the classic examples you get are exactly the ones like, oh, change the color of the homepage, or, you know, make a little tweak to the icon, tweak the CSS. Basically small tweaks. And small tweaks in the sort of maturity cycle of a product, they help really at the beginning here. Right? So that's when you start out, you really don't know quite what you're doing, you realize something, then you can make small tweaks, you can get a lot better. But the reality of small tweaks is that they reasonably quickly approach some kind of asymptotic level. There's actually not that much you can squeeze out of a particular product or feature by incrementally improving it. So you reach this kind of point of saturation, which is almost impossible to see here. At some point, you have to realize that you're hitting a point of no return or diminishing returns, and then you have to make another big leap, the great leap forward, I guess, of innovation. And so Spotify, again, talks about this in much more detail, how you have to like pair this notion of tweaking stuff, and then you have to really risk something and try something big. And then if that works, then you can tweak it again, and that's the way you kind of keep growing. So even if we get rid of the idea of software projects, you still have this moment in your life cycle where you're making big changes as opposed to small changes. And I think the only consequence I can draw from that, and I've seen this work pretty well in a bunch of organizations, is to accept it. You know, you are going to have multiple pipeline patterns within your organization, especially those of you who are more than 100 people. And even those who are less than 100 people, as your single product maybe matures over time, the kind of pipeline pattern that is relevant will need to change. So you need to kind of think of an approach to this. All right, metrics, metrics, metrics. So I spoke a lot about like this, the importance of this beginning piece of the pipeline, which is really not automation at all. It's just like remembering that there's an idea behind stuff. Now let's focus on the other bit that is really the automated part of the pipeline, the kind of classic bit that we know. And you've got like Puppet or Mantle or Chef or Docker or Kubernetes. Choose your poison. There's like so many of them out there. One of the things I think that's worth pointing out is that often the discussion in this area is around what kind of provisioning tool do we need? What kind of OS do we need? What kind of cloud provider do we need? And that's all important stuff, but that stuff is really, I mean, that's an enabler. The pipeline isn't there so that you can have a bake-off between Puppet and Chef and Salt and Ansible. Like the point of a pipeline is to give you data about your product or project, right? It's to give you just enough data so that you can be confident that you can hit that big red button, and that if you hit that big red button, good things will happen. The automation is just a way to make that work. And what's the reason I'm emphasizing this is because for a lot of people, testing is like the thing we do last in the pipeline. We'll figure that out once we have the automation done, which is totally back to front. If you don't have tests in your pipeline is just a big automated accelerator into risk land. Like, that's not particularly smart. And I've lived through that, so you know, I'm not that I'm saintly. Basically, the question is, so I talk about, you know, a pipeline is there to give you confidence to release. But what can you be confident of? So you've got this new version out there. It's like the best thing you've ever built, and you want to get it out there into production. So can you be confident that this version is going to be so good, just better than the one you have out there right now? And if you talk about pure functional use cases, yes, you probably can. You can count the number of functional test passes, and you can count the number of functional test passes in the new version, and then you can do a count, you know, X greater Y. But better is more than just functional test cases that you've ticked off. And I think the reality with modern, complicated distributed systems is that it's almost impossible up front to know for a fact whether the system's really going to be better in all aspects. Like, I'll give you a nice example. I'm getting my hands dirty with an AI system right now. Really interesting machine learning problem, you know, parsing data, NLP, lots of cool stuff. Like, it's impossible to know before you go live what your performance is versus the current version. You can make a statistical estimate, but you don't know for a fact. And you have to measure quite a long time after you go to production to really have some kind of statistically significant solution. And the same goes for load testing. I mean, I think, well, let's skip this question. I'm getting a bit short of time. So I think the other type of confidence you can have is that it won't end like this. And it's really important to keep these two apart. Like, one is confidence that you're actually going to get better, and the other is confidence that you're not going to fail catastrophically. And those are two different things. And it's much, much, much easier in a pipeline to determine whether you're at risk of failing catastrophically or not than you are to actually know whether you're going to get better. Unfortunately, if we're trying to talk about preventing catastrophic failure, then the kind of classic functional and static code analysis, cyclometric complexity, all these kind of stuff, they're pretty useless at telling you whether your system is going to survive in production when you get out there. And that's why I'm here to talk about architectural metrics, so not cyclometric code complexity. What I mean by this is the kind of information that, you know, we can collect about our systems that will tell us whether it can scale, whether it will perform, and so on. And that's very hard. I mean, I don't know, you know, I think we all know setting up a load testing environment that has sufficiently accurate test data, performance, and behavior that we can be really confident that it will replicate what happens in production. Incredibly hard. It takes forever. You certainly can't do it on a sort of day-by-day basis. And the trick is, you don't actually need to replicate production performance to get an indication of whether you're going to do something catastrophically wrong. All you need is anomaly detection. Like, you need to, you know, you need to be able to have a baseline for what kind of metrics we expect the system to have. And if it goes really crazy, then you have a problem. So for the next couple of slides, thanks to Andy Grabner, he's a performance guy from Dynatrace. He got some of these metrics out. We did some work together on this problem. So here's the kind of use case. So we have some tests. Like, we all know this. Oh, test case. These are just standard unit tests, and you know, they're good. And then bang, we break something. Okay. And then the developer goes in and fixes the code, and oh, look, it's green again, and everybody's happy, and then we deploy to production, everything dies. And then we ask ourselves why the build was green, what went wrong? And so, you know, imagine that you could have these numbers, you could measure not just red or green on your functional tests, but also things like how many SQL statements are you executing? How many exceptions are being thrown? What's your CPU utilization? Blah, blah, blah. So this might look like this, everything looks okay, and then we have a few errors because stuff failed. Well, that's unsurprising. Then we fix it, but by fixing it, we tweak the Hibernate configuration to do n+1 loads, lazy loading versus whatever, and now suddenly our functional tests are all green, but we've totally changed the characteristics of our system. This is the kind of stuff that brings down your systems in production. You scale up, suddenly your database has 10,000 connections open to it, everything dies. Like, that's catastrophically bad, and you will not see that from your functional data. So the point is, can we make use of this information during our continuous delivery pipeline to give us kind of architectural confidence in our system? And the good thing is that we can, of course. And I mean, this is one of these, like, you can take this home tomorrow, because it doesn't matter what tool you have. Chances are you have some kind of APM-like tool, or Nagios, or New Relic, or something. Like, that data is in there. That's the data you need. What you need to figure out is how to incorporate that data into your pipeline. And some of the tools do better than others in doing that for you automatically. But you have the data. Like, it's all there. You don't need to do anything funky. So, long story short, what we typically measure in terms of metrics for our application during testing is like this stuff. Did tests fail? How long did it take? And this is the data that's actually still there that we don't use, or we use very rarely. And there's much, much more than this, obviously. Like, you know, how many layers of overlay networking, how many bounces through HA proxy, blah, 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 blah. There's so much stuff that can give us a much better level of confidence, and we really don't use it. So I'll give you some instant examples, because I see I have like 8 minutes left. So here's a couple of nice examples. And how does this relate to microservices? Well, all these examples relate just as much to microservices as to any other application. Microservices is especially important because those of you who are thinking of trying to transition an existing application to microservices, you are going to be making fundamental architectural changes to your application. So it's almost inevitable that you will be fundamentally changing the architectural characteristics of the application. And that will go wrong. No problem. That's how we do it, right? We do it, we fix it, we learn. But this is especially important, and I'll weave in some microservice-specific examples here. So this is an interesting one, very simple. So what was happening here? Well, the functional test passes, but you've got missing files, they delay the response time. You've got, you know, you factor something out, make lots and lots of calls. Instead of bundling them up into one, there's just lots of traffic going on there. Overlay network stuff is slow. Lots and lots of stuff going into the database. Not very good. And if, you know, this could be 10x from what you had before, and so then this is the kind of stuff you want to know. Here's a microservice like refactoring example where they pulled out the, I mean, this is really bad microservice refactoring, if you ask me, because it's classic service-oriented architecture. Pull the layers apart as opposed to pull the business functions apart. But they pulled the front end out into a service, and then they pulled the detail thing out into a service, and then they had a storage service, otherwise known as a database. But of course, they messed up a little bit. So first of all, they forgot to have all the access going through the middle tier, so you had that happening. And of course, they, you know, because if you write a nice API, bulk queries look, they look ugly, so you just make them query one by one. But suddenly you're querying all this stuff over a network. And then you know, what was happening in practice here is they were getting an account, and then for the account, they were getting the details. And instead of one batch call to the database to, you know, get me these 50 customers with all their details, which is a join on another table, they were getting 33 times the details as a separate call, blah, 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 blah. And that takes a long time. And that breaks. I'll give you another example for which I don't have such a nice graph, because this is one we experienced recently. Mongo sort. So we had a query. We were running a query against Mongo. It had a sort and a filter, and everything was running really nicely. And then we tweaked the query a little bit, and we ran into something fun called Mongo split index stuff. So Mongo is able to join indexes that you have, but not under certain really small edge cases. And we ran into one of these edge cases, which meant that instead of the filter happening in the database, it was loading everything into memory that the sort returned, that the query returned, and then trying to filter and sort it in memory. And it went bang, unsurprisingly. But this is the kind of stuff, memory usage of that node would have shown this like immediately. So this is the kind of data that's important. And so what does this look like? Well, you know, in some tools, this is Dynatrace. You get this really fancy graph and all your tests. What's important here, I think the interesting bit is this auto baselining stuff. Like, that's what makes this work. That it doesn't really matter what the metrics are, or even whether they're 100% production equivalent. What matters is that you can track them within a range, and when they go out of that range, you get a big alert. And then, you know, you include them in your pipeline, and then they're just simple tasks that happen somewhere along with all your other stuff. So, pipelines, they're about gathering data. It's much easier to get to the level of confidence that you're not going to break stuff catastrophically, and architectural metrics are really good for that. Right, beyond go live, interesting bit. So, I'll come back to two statements I made at the beginning of the presentation. One is that CD is not about commit to production, but it's about ideas to users. And the other one is that, you know, it's actually hard to gain confidence about how well your service will be exactly when it goes to production. So the logical conclusion, I guess, is, well, the pipeline shouldn't stop when we go to production. Like, users are not, they're not sitting on your production servers, they're somewhere else. They use your service later. all that kind of stuff. They use it through mobile devices, whatever. And similarly, that's what you need, both the time and the kind of distance in the pipeline. So you need to extend it beyond the go live. You need to say, okay, now we do the deployment, and now we need to go and figure out whether we actually did anything useful. But what do we measure? What do you measure to try to figure out whether your service is good? And again, this unfortunately turns out to be a surprisingly hard problem. All these tools give you wonderful data. You can get the low-level technical stuff, server CPU usage. You can get some higher-level stuff like, revenue rates and conversion and, clicks from Stockholm Central or whatever. So there's a bunch of data you can get, but that just because the data is in a dashboard doesn't mean it's the right data. And I'm just going to give you some ideas because I don't think there's a right answer. There's a lot of technical stuff, but what we're really trying to get at is to try to understand the user experience. And you can see companies trying different approaches to this problem. So some of them, they have that feedback button. If you've used some SaaS applications, there's a little boink that pops up. Do you like this new feature? They throw stuff in your face. They ask you for surveys. I know other companies monitor Twitter, get the social dimension to try to see what people say about their service. They look at referrals. You can do traditional UX testing. Obviously, a large element of this is heavy client-side telemetry, like instrumentation. Actually write code in your code to figure out how people are using it. And why is this interesting? Why is this important? It's because it can lead to this magical notion of more user-focused teams. I had an interesting discussion with someone from Netflix who said, look, you can build all the pipelines you like until your organization accepts that your product managers don't know everything, and that you're actually just as likely to get ideas wrong as you are to get ideas right. You will never be able to compete with us. Pretty aggressive statement, but he wasn't saying it sort of to make Netflix look good. It was more than saying, it's not about the technology. It's about that cultural shift. And I mean, so Amazon, this is Amazon's #1 leadership value, customer obsession. Like, I know, because I've been in them, there are meetings in which somebody from Amazon says, they have some technical discussion, they say, what's best for the customer? And that decides the decision. This isn't easy. Like, this is an interesting study Microsoft did with an interesting link. Like, even Amazon, 50% of the experiments they put out there fail. Microsoft, they reckon about 1/3 of the features they put into Bing have a positive impact on the user, about 1/3 do nothing, and about 1/3 have a negative impact on the user experience. Like, that's the reality of thinking about and delivering features and software. And of course, this is not like I need to, there's a financial regulatory compliance thing and I need to be able to send back this XML document. And we're talking about different kind of requirements here. But the challenge here is if you want to get to that level, it requires organizational and cultural change. This is Mad Men. This is like an advertising series from the 50s. And a lot of this is, to some extent, outside our hands, where we are in the sort of development or IT area. This is really a product management culture question, an organizational leadership question. But that's what the really successful companies use continuous delivery to do, to leverage the power and the imagination of their developers by hooking them up with their users and admitting that the best thing we can do to be a successful company is to let people try safely and fail and then roll back and try again. So, some takeaways, really quick. You can read the slides, I have 30 seconds. CD is not about ideas, it's about ideas to users, not commit to production. And as your application or service goes through phases, you're going to have different patterns for your pipelines. Think about using the right kind of metrics to get confidence when you go live. And think about how you can go from a sort of just build what we tell you culture to an actual experimental culture. So we're almost there. Just for fun, because it's always good for people to learn something totally different. There's a character called the Zero Width Joiner. This has nothing to do with continuous delivery, but it's fun. It's a Unicode character, and what it does is it makes characters be connected. So this is important in certain languages, Arabic and other languages, where you can basically, by adding this character, you can see you get a totally different thing. But the reason I'm showing you this at the end of the conference is because you can use it for fun stuff. You can use it with emojis. So you can take these 4 characters, which are man, woman, girl, boy, and you can add this Zero Width Joiner, and then you get this. Isn't that cute? So one of them is Android, one of them is iOS. So yeah, that fun stuff. And with that, please remember to rate the session, rate the conference. I hope you had a really good time. Thank you very much.
So a couple of questions.
Because it's the best. The emoji slide. It's not up anymore.
What tools are you using for architectural data testing?
So we are duct taping together what we have, right? So we have New Relic. That was there before I started messing with the system. So we are using that, and we're hooking that up into our Circle CI flow, which is our pipeline. And of course, for some of our other products, we're using our own products, so we dog food our products, so XR release uses, you know, the New Relic data, or we have some Nagio stuff, and we've handwritten some instrumentation as well. So we basically use dtrace and some of those things to get some low-level metrics. But our use of this stuff obviously only goes to the point, you know, where we feel we have enough confidence. I mean, this is not the thing where you say, oh, good, I heard this nice idea at a conference. Let me spend the next 3 weeks adding all these metrics in there, right? What you need is confidence to go live. And if you feel you already have that, and in practice things don't blow up, then you're okay. It's once you start to see that maybe things don't always work out too well, that's when you need to start to figure out, so what kind of problems do we have in our application? What would it make sense to measure?
Okay. So of all the metrics that you use, which one do you find the most important?
For JVM applications, typically memory. So memory usage. Because that's, you know, memory leaks, that kind of stuff. File descriptors is another one, depends a bit on the kind of application. For container-based stuff, anything in these sort of microservice-y container-based environments, network, the size of stuff going over the network and the number of network calls is a very big component. Because, you know, anybody who's run Docker Compose up on their local machine, it's lovely. It's a local host, like, boop, everything's super fast. But then if you stick it on a Marathon or a Mantle or a Kubernetes cluster, and maybe you've got it high available, you know, across multiple availability zones, and suddenly your service scales out to where some of the nodes are in a different AZ, and as we all know, Amazon's network connections across different AZs is not so great. So yeah, having a good handle on how much network traffic you're pinging around is really important.
Good. That's it.
Thank you very much.
Thank you. Keep an eye.